Welcome to another exciting educational video brought to you by Upvision Concepts Academy. In this video, we'll be looking at acid, bases, and salts. And we'll start by the definition of acids. Acids are substances that release hydrogen ions in aqueous solution. So acids are substances that releases hydrogen ions, that is H positive, in aqueous solution. So when you put acid inside aqueous solution, this ion is released. Okay, so we have two kinds of ways to identify an acid. You have the anhydrous acid, and we define it as the one that produces hydrogen ions in water, and we can identify it by this method, the Bronsted-Lowry acid, and it is seen to be proton donor. So any one that comes in your exams, you know that these two are definition of acid. You can define it as a proton donor, but if you are looking at it through the Bronsted-Lowry acid model, or you can say it produces hydrogen ion in water. So examples of acid include hydrogen chloride or hydrochloric acid, sulfuric acid or H2SO4, okay, and ethanoic acid. So these are examples of, these are organic acid. These are examples of acid. So properties of acid. Number one, properties, let me just put it this way, properties of acid. So what are the things you will see that you make you know that it's an acid? Number one, it has sour taste. It has sour taste. It's not tasting sweet. Number two, it turns blue litmus paper red. It turns blue litmus. Litmus paper is what we use to identify acid in the lab. Paper red. So it is blue to red. And number three, it conducts electricity in solutions. It conducts electricity in solution. There's a fourth one, though I don't have a space to put it, but I'll call it out. It reacts with metals, bases, and carbonates. Okay, I can put it somewhere here. Number four, properties. It reacts with metals. Metals can react with bases. We'll look at bases in the next one. And carbonates. So these are the things it reacts with. So it's actually very reactive. Properties is that it has sour taste. Secondly, it turns blue litmus paper red. And thirdly, it conducts electricity in solution. Finally, it reacts with metals, bases, and carbonates. So we'll move on to the next one, bases. So bases are substances that releases hydroxyl ions in solution or accept proton. So I say they are substances, bases, okay, are substances that releases hydroxyl ion, this is how it's abbreviated, in solution, or they accept protons. So they accept protons so that they can become neutral. Okay, so you have two models of defining a base. I can say the anhydrous base produces hydroxyl ion in water. Okay, and I can say Bronsted-Lowry base is a proton acceptor. Acceptor. See, why the one of acids, this model, anhydrous acid produces hydrogen plus in water, understand? And this bromelauric acid is a proton donor. So that is for the other one, the first one we defined. Now the second one is the flip side. It's the flip side. So example of base include sodium hydroxide. Examples, let me just put it here. Examples include sodium hydroxide. Sodium hydroxide. I have potassium hydroxide. So these are called the alkalis. Okay, so I have ammonia. Ammonia is a weak base actually. It's a weak base. Ammonia is a weak base. And you have calcium hydroxide. This line. Manganese hydroxide. So these are the examples of base that we have. Okay, so we'll go on to properties. What are the properties of base? Properties of base. Please note all this in your exams. Number one, it has a bitter taste. So it has a bitter taste. Taste bitter. Or soapy feel. Soapy feel. Okay. Second property here, it turns red litmus paper blue. See the flip? Turns red litmus paper blue. Okay, at this point, let me just introduce a mnemonics, a short way of remembering litmus property of acid or base. Acid turns blue litmus paper red, ABR. Base turns red litmus paper blue, BRB. So if you know this acronym, this mnemonics, ABR for acid turning blue litmus paper red, and base turning red litmus paper blue, you can always get it. You won't miss it. Okay, so the third property is that it reacts with acid to form salt and water. Okay, so in the process known as neutralization, we'll talk about that later. But as a property, it reacts with acids to form salt and water. To form salt and water. So these are the properties of base. The properties of base. So the next one, we'll look at alkalines. Alkalines are actually solutions, soluble bases dissolved in water. So if you dissolve, I mentioned this is what alkalis. This one, alkalis, sodium hydroxide and potassium hydroxide. So if you dissolve them in water, what happens? They give hydroxyl ion. That's this ion, OH minus. Okay, they give hydroxyl ions. All right, so these are alkalis. Okay, so we'll move on to salts. Salts. So what is salt? So salts are ionic compounds. Ionic compounds formed when hydrogen ion in acid is replaced by a metal or ammonium ion. Very good. So salt is formed when this ion in the acid is replaced by a metal or ammonium ion. For example, if I have HCl, acids are formed when hydrogen ion is replaced by a metal. Okay, so and it reacts with maybe this one. It can give me sodium chloride plus hydrogen evolving. So this is 2, this is 2, and this is 2 here. Okay, and this is 2 here. Okay, so this one is an acid because this metal displaces it. You understand? And when it displaces it, it forms this ion. Okay, so types of salts. Okay, so you have normal salts. Okay, actually this example is not an example I will need for this, so just forget about this. Let's just go ahead. I would put up the example for you. So we have types of salts. We have the normal salts, types of salts. Number 1, we have normal salts. Number 2, we have the acid salts. Number 3, we have the basic salts. Okay, what are normal salts? Normal salt is when all the hydrogen ion is replaced, leaving nothing. So if you replace all the hydrogen ion, you'll be having things like this. Example, you also have things like potassium nitrate. Okay, so all the hydrogen ion is replaced, and this kind of salt you have. Normally, what is replacing it is this metal here. Before, it used to be hydrogen that is with having sodium's place, that's combining with chlorine. But sodium came to displace hydrogen, and hydrogen comes out, and you have this. So normal salt is formed when all the hydrogen ions in the acid is removed and replaced by a metal. But acidic salt is partial displacement or partial replacement. This one is all replacement, partial replacement. So when you have partial replacement, what happens? You now be having a residual hydrogen inside. For instance, sodium hydrogen sulfate is an example of acidic salt. Normally, if there is no hydrogen here, it should just be sodium sulfate. But right now, hydrogen present here still makes it a salt, but it's an acidic salt. The hydrogen is the acidic component in that salt. So basic salt contains hydroxyl ion, OH minus, or it contains O2 minus. So example of basic salt is manganese chloride that has hydroxyl. Okay, so we'll look at the strength versus concentration. When we talk about strength of acid, we'll look at strong acid, weak acid, concentrated acid, and dilute acid. So a strong acid is it completely ionizes in water. So if you see a strong acid, you will see example of a strong acid. Okay, let me talk about strength of acid. Or let me just take this off so that you can have a good okay, so strength of acid, strength versus concentration. You see this a lot on your objective style questions. So if I have a term here, I will explain what it is. Explanation. So the first thing I want to talk about is strong acid. So strong acid. Secondly, I have weak acid. Thirdly, I have concentrated. So when you hear the word concentrated or when you hear the word dilute, what does that mean? What does that mean? So if I say strong acid, what I'm saying here is that it completely ionizes in water. So example of this can be HCl. Another example can be HNO3. That's hydrogen nitrate. Okay, so this one is complete ionization in water. Okay, now for weak acid, there is partial ionization in water, so that the part that is combined, hydrogen is combined with, we still have hydrogen inside. Yes, and see, hydrogen is pairing with a non-metal here, and you don't have any hydrogen component again. But for weak acid, you'll be seeing hydrogen inside the compound or radical is pairing with. Okay, so this is where you have partially ionized in water. So example of this kind of acid, weak acid, is this one. So this one is a weak acid. Okay, then concentrated acid is large amount of solute per volume. So when you talk about concentration, you have large amount of solutes per solution or per volume. Of course, not a solution, but per volume. So solute is mixed inside the volume, and you have so much. And this one is the flip side. Small amount of solutes, per volume. So this is the flip side. So we're hearing terms like this: strong acid, weak acid, concentrated acid, dilute acid. This is what it means. So we'll go over to reaction of acid. Okay, so we'll go over to reaction of acid. So reaction type, for first here I have acid and base, acid plus base. This one is known as neutralization reaction. We'll look at it. This one will give us salt and water only. Understand? So if you have acid and base, it will give salt and water. Example, I have acid, HCl, plus sodium hydroxide. That's acid and base. It will give me salt, this, and water, this and this. You understand? So that's the first type of reaction. The next one is acid metal. Acid and a metal. How does it go? That is, if acid reacts with metal, it will give you salt and hydrogen. Example, if I have this is acid, 2 hydrochloric acid plus a metal, zinc. What it will give me? It will give me a zinc chloride, displacement reaction, and hydrogen is coming out. It's coming out. Okay? So the third kind of reaction that acid will go is acid plus carbonates. Acid plus carbonates. So I have acid and carbonates is giving us salt, carbon dioxide, and what again? Salt, carbon dioxide, and water. Okay, let's put an example. If I have acid, H2SO4, reacting with a carbonate, this is lime, what they call lime, calcium carbonate. Okay, so what will it give us? This one goes with this to give us calcium sulfate plus carbon dioxide and water. Okay, and the last kind of reaction acid will go with, it will go with ammonia. Ammonia is nitrogen and hydrogen. So if acid reacts with ammonia, it will give us ammonium salts. So the example is acid, HCl plus ammonia will give me ammonium chloride. Okay, so we'll move on to preparation of salts. So we'll go on to the preparation of salts. So the first one I will look at here is soluble salts. That's group 1 and group 2. It is made from titration, acid and alkaline titration for soluble salts. Example is sodium chloride from HCl and NaOH, that's sodium hydroxide. So insoluble salt is made for precipitation, double decomposition reaction. Lead sulfates from lead nitrates, and sodium sulfate. Okay, soluble salt again for group 2. Soluble salt for group 2. You can have acid here. For this particular one, you can have acid plus metal or metal oxide. Example is copper sulfate from copper oxide and hydrogen sulfide. Okay, so pH indicators. What are pH indicators? That's pH scales range is between 0 to 14. So if you have a pH scale less than 7, let's say you put the pH indicator into a solution or a substance, and the reading is between 0 to 1 to 5, less than 7, it means it's acidic. But if it's 7 on the dot, it means it is neutral. And if it is greater than 7, it means it is basic. So these are the indicators. So you see litmus. I told you about litmus. Acid turns red, litmus paper blue. Okay, so under indicator, apart from litmus paper, you have methyl orange. So acid turns red, methyl orange. You have methyl orange. You have phenolphthalein. Okay, so know the indicators. Okay, let me put it on the board so that you can see. So a quick one on the board. So these are the indicators that we have: litmus, methyl orange, and phenolphthalein. So these are the 3 kinds of indicators that we have. So for acid, on litmus paper it's red. Once you see red, it means that's acid. And you will see on methyl orange it is red, it is acid as well. On phenolphthalein, if it is colorless, it's acid. For base, if it is blue, that means it's base on litmus paper. On methyl orange, it is yellow, that means it's base. And on phenolphthalein, it is pink, that means it's base. So note these different indicators and the color that pops up when acid or base is introduced to them. It's a way of letting us know what the substance is by the color code. Okay, so finally we'll talk about hydrolysis of salts. So some salts react with water to form acid or base solution. Example of an acidic solution is when you have ammonium chloride. Ammonium chloride is an acidic solution. It's an acidic solution. What else? I have sodium carbonate. Sodium carbonate is a basic solution. These are salts that are undergoing hydrolysis. Hydrolysis means you are introducing water to it. And sodium chloride is neutral. It's neutral. So these are the kinds, the salts. So this salt is acidic. This salt is basic. So this salt is neutral. Why is it acidic? Because there's hydrogen, extra hydrogen attached to the radical chlorine. So in summary, we have learned a lot today. We are seeing that acid produces positive hydrogen ions. pH is less than 7, and that it has sour taste, and litmus paper red is the color. So it turns litmus paper red. That means when you put acid in the litmus paper, you will see red. From blue to be blue, but to be now be red. Okay, so bases or alkalines produce hydroxyl ion, and the pH is greater than 7. So it is bitter, and the litmus paper is blue when you put this substance in it. Salt is just a metal that replaces hydrogen, in acid. When a metal replaces hydrogen in the acid, it becomes a salt. And pH, for pH values, strong acid is 0 to 7 or less than 7, and neutral is 7. While from 8 to 14, you have a strong base. Okay, so okay, I'll put it this way. For strong acid, you have 0 litmus. For neutral, you have 7 litmus, and for strong base, you have 14 litmus. Okay, so indicators, common indicators are litmus paper, phenolphthalein, and methyl orange. So we can prepare salts by titration, we can prepare salt by precipitation reaction, and with acid. So I hope this video has been informative for you. I'd like to thank you for viewing.